Hey everybody, welcome to Programming with Benu. This is Benu Digbali, and in this video, you're gonna learn how to build cross-platform desktop apps with Electron. But first, let me talk about Electron itself because it's so important to know how Electron actually works. So, what is Electron exactly? Electron is a JavaScript framework for building cross-platform desktop apps using JavaScript, HTML, and CSS. It's developed and maintained by GitHub, and it's based on Node.js runtime on backend and Chromium rendering engine on frontend. Electron is widely used by big companies like GitHub, Microsoft, Facebook, and Slack. Now, here's the thing. To understand how Electron works, first we need to understand how a modern browser works, and specifically how Chromium works, because Electron is based on Chromium. Okay, so this is the Chromium's recent architecture. This is the diagram of Chrome's multi-process architecture. At the top is the browser process coordinating with other processes including utility process, GPU process, plugin process, and renderer process. For the renderer process, multiple processes are created and assigned to each tab. Each process controls something. For instance, as you can see in here, the browser process controls address bar, network request, and bookmarks. And the render process controls anything inside the tab. Over the past 10 years, the Chrome team has implemented two different architectures or process models in the Chromium browser: the single process model and the multi-process model. In the single process model, as you can see in here, all web content and browser components share fate in a single process. In contrast, the multi-process model can isolate web program instances and their browser components from each other and from the rest of the browser. So technically the multi-process architecture is more powerful, and Chromium effectively implements such a multi-process architecture. In the JavaScript world, loading fast is important. Loading fast improves performance. When the navigation begins, the first pane shows up on the screen. The loading process goes on until the loading lifecycle is completed and the page is fully loaded. The best way to make sure that your site is performing its best is by implementing architecture best practices. The purple pattern was created to help modern web applications achieve top performance values. The Google Polymer team developed Purple as a guideline to follow to help websites perform better. Purple is more about a mindset and long-term vision for improving the performance of the mobile web than it is about specific technologies or techniques. Purple stands for push or preload, render, precache, and lazy load. And by the way, this diagram shows how the purple pattern works, and as you can see, I circled the preload because we're gonna get a closer look at it later in this session. So how Electron works. As I mentioned earlier, Electron is based on Chromium rendering engine, and because of this, Electron inherits its multi-process architecture from Chromium, which makes the framework architecturally very similar to a modern web browser. So basically, Electron has the same functionality as the browser. Each Electron app has a single main process, which acts as the application's entry point. The main process runs in a Node.js environment, meaning it has the ability to require modules and use all of Node.js APIs. The main process controls three parts of the application: the window management, the application lifecycle, and the native APIs. In order to implement the main process in Electron, we need to have a JavaScript file in our application structure named main.js. The primary purpose of the main process is to create and manage application windows with the browser window module. And by the way, this is a typical main.js code, so we can see what's going on in there. Each instance of the browser window class creates an application window that loads a web page in a separate renderer process. If you notice, I underlined the preload.js and index.html. This is because we need to insert them in the browser window class. The main process also controls your application's lifecycle by Electron's app module. This module provides a large set of events and methods that you can use to add custom application behavior. For instance, quitting your application. To extend Electron's features, the main process also adds custom APIs to interact with the user's operating system, for instance, native desktop functionality like menus, dialogues, and tray icons. Each Electron app generates a separate render process for each open browser window. A renderer process is responsible for rendering web content. So all user interface and app functionality within a single browser window should be written with the same tools and paradigms that you can use on the web. One important thing to remember is that the renderer has no direct access to require or other Node.js APIs. In order to directly include npm modules in the renderer, you must use the same bundler toolchain, for example, Webpack, that you can use on the web. By the way, this code snippet shows how to include the renderer in the HTML file. Preload Scripts contains code that executes in a renderer process before its web content begins loading. These scripts run within the renderer context, but they have access to Node.js APIs. Okay, enough talk. Let's see how Electron works and what it does. I'm going to show you three different demos so you can totally understand what you can do with Electron. So let's go. Okay, the first demo is about adding Electron to an existing project. So for this demo, I added Electron to my previous React login project, which I showed you in the previous video. All I needed to do was install Electron and add it to the npm scripts. Then add a JavaScript file named electron-started.js and then define the main process like the browser window, settings, and the loading path, as you can see in here. After that, add the file path to the main entry in the package.json, this line. And finally, run the app. Let's run it and see what happens. So let me run npm start. Okay, this is the app which runs in the browser, but we don't want this. We want our app to run in the desktop. So all we can do is run it with Electron. Okay, now we have our app running on the desktop. So this is what we wanted. Okay, the other way to build Electron apps is by using boilerplates and builders. There are some Electron boilerplates and builders that you can find and use. For example, there is Electron React boilerplate for your React projects. There is Electron Vue boilerplates for your Vue projects, Electron boilerplate, Electron Builder, and Electron Forge. Okay, let me show you how you can use these boilerplates real quick. For example, for this demo, I cloned the Electron React boilerplate. Let me show you how it works. npm start. And by the way, this may take a few seconds. Okay, as you can see, this is the Electron React app. And if you want to build your own Electron app from scratch with Webpack, I recommend using this repo, Electron Webpack. You can learn more about this repo on GitHub, and there's a quick start. You can clone this repo, then install dependencies, and then run the application. I hope you enjoyed this session. Thanks for watching.